So we've used a function called rnorm to print a set of numbers with a particular property of belonging to a normal distribution, and I've said that this is something called a vector. We can create our own vectors manually using a function, and a particular function is called C, which just stands for combine. Inside brackets we can type the numbers that we want to combine into this vector, and I've assigned it to a variable called x. So this is going to change my value of x. At the moment it's 100, and it now changes to something called num 1 to 4, which is meaning that this is a vector containing 4 numbers, and these are the 4 numbers. If we wanted to, so this is a collection of numbers with a particular order. So this number 3 is always the first in the sequence, then 4, and then so on. If you wanted to print out what is contained at any particular position, any element in this vector, we can type the set of square brackets after our vector and type in a number, say number 1, and this will print out 3 because 3 is the first element in this vector. And in a similar way we can type x square brackets 2 and x square brackets 3 and so on. Or we can create another vector. So let's say I create a vector which is containing the numbers 2, 3, 4. Now I'll give you a moment to think about this. You can pause the video if you like. What do you think would happen if I type x and then my y inside square brackets? So you can pause the video now, think about that, and then I'll talk about what the solution is. So what's going to happen here is, you can think about if you did this in stages. So x2 would return the second item in the vector. Oh, I'd actually run that. x3 returns 5, which is the 5th element in the vector. So x brackets square brackets c 2, 3 will return the second and third elements in this vector x. So in other words, I get the numbers 4 and 5 returned. And then 2, 3, 4, if I put that in my brackets now, it returns the second, third and fourth, which is the numbers 4, 5 and 6. And so putting x, subsetting, so inside the square brackets I put y, is the same as putting the vector 2, 3 and 4 in here. So I get the numbers 4, 5 and 6. So this is slightly, it's probably slightly abstract at this point, but when we get to looking at tables, so tabular data like you would have in Excel, we sometimes might want to look at what's in particular rows at particular positions, and we'll use these kind of techniques. Vectors are pretty useful in R. Because we can do arithmetic on them really easily. So my vector, well, let's create a new vector saying which is all numbers between 1 and 10, and I'm actually going to cheat and use a shortcut, which is to put a colon here, saying it's a quick way of generating a sequence. So if I want to multiply everything in this vector by 2, I can do that really quickly now by typing x, the multiplication symbol, and then 2. So I now get all my numbers 1 to 10, and every item that is output is the corresponding element in x times by 2. So this is 1 times by 2, 2 times by 2, 3 times by 2, so on. And some languages you would have to do something a bit more complicated. You have to write some structure called a for loop and multiply every number in turn by 2, which is a bit time consuming, but it can be done. You can raise everything to a power. So this symbol takes everything x, raises it to the power 2, or in other words, does the square root. The square, so to the power 2. The square root would be something called sqrt. So if I did the square root of brackets x to the power 2, I would get back to my original x, for example. We've done, we can do these operations on numbers, and we can do that because our vector x contains only numbers, and that's the general rule with a vector. If you want to use a vector to store some data, every element in it has to be the same type of thing. You can create vectors that contain text as well. These are often called character vectors. So I could have a vector of letters A, B, C, D, E, for example. X. You notice that I wrote quote marks around here, each of these letters. If you try and do that without, so if you want to write any kind of text or characters, it always has to be in the quotes. If, for example, you did try to run this kind of thing, I would think you were referring to an object called A. So remember, we call things like X and Y without quote marks, and if we type A without a quote mark, it expects to be able to find an object called A, which it can't do, so that's why you get that error message. Another useful type of data you can have is something called, it's either called a logical or a Boolean value. And these are values which can only be true or false. And notice it puts it in blue because these are special words in R that R already knows about. So it might not be particularly obvious why you might want to do this. Most of the time you get a vector containing logical or Boolean values when you've done some kind of test. So if I could create a vector called x containing the number letters A again, let's have a B, let's have another A, let's have a B, so on. I could say, so let's say I wanted to know which elements in this vector are the letter A. So I can say, and the way you would do that is to put two equal signs next to each other and then put the thing I wanted to check if it's the same as. So if I say x double equals A, what I get is a set of true or falses in positions that correspond to whether the item is an A or not. So first item is an A, so I get a true as number 1. Second item is also an A, so I get a true. Third one is a B, so I get a false. So, I mean, it's quite abstract. Imagine if these were gene names, for example, or names of drugs or something, that people have been treated with particular drugs. You might want to look for, search in your data set for where you find a particular gene name, where you find the data for a particular gene. Other types of comparison we can do on numeric data. Let's create a set of 10 normally distributed numbers. We might want to know which of our numbers are greater than 0. So I use the greater than sign, and 0 is the thing I want to compare to, and it will give me a set of true or falses depending on which of my elements is greater than 0. So the practical application you might have here is you might want genes whose expression level is greater than a particular threshold, whose p-value after testing is less than 0.05. So you could say less than 0.05, for example, and you could identify those results in your data. At the moment we don't really have any data because we've been typing in numbers manually, but in the next section we'll look at how we can import data into R and start to manipulate it.